One area I had hoped to touch on yesterday, we can speak to today, and that is around data visualization. Because as the weight of inputs increases, both in numbers and in type, it becomes increasingly greater a challenge to make it digestible, particularly as the urgency, both caused through computational speeds and expectations around decision making, become greater. As one of the panelists just said, the quest is really for insight as well, which presents a further challenge to visualization experts and designers. This is a particularly interesting thing to look at because historically, it's not a cliche, many of the people involved with this do not have a lot of experience in graphical representations of information. They're used to rows and columns, and those kind of skills are becoming increasingly more urgent for this practice. I didn't say anything about China. So here from Stamen Design, which is a leader in the field of the visualization of data, we have Alan McConchie. Alan, thank you.
Hey, hi everyone. I'm Alan McConchie. I am a design technologist at Stamen. I'm also doing a PhD in geography at the University of British Columbia. Stamen is a design and technology studio. Defining what we do has actually been one of our major challenges. One thing we do is we design and build live dynamic mappings of rich information data sets. Kind of wordy. We're trying to talk about what we're actually trying to accomplish in our practice. We tend to use the term data a lot. We tend to use design, visualization. One term that we find we never use is data science. We're not really data scientists. We tend to work with data scientists from time to time. But we're a client-based practice, so people come to us with some data that they need visualized. And usually they come to us maybe after their data scientists have worked on it, or when they want to go in a direction with their data that they can't do with their in-house skills. So we do maps, we do design, whatever that means, and we do data visualization, whatever that means. But we in fact had a big discussion at the studio within the last few weeks. We're trying to figure out what term we should be using, what one sentence phrase, catchphrase can we use to describe what we do. And everyone's attempts at that involve the word data, even though we all really were struggling to not say visualization or not say design or not say mapping. I was actually surprised that no one in the studio, there's about 14 of us, really felt uncomfortable with the term data. So hopefully we have something in common with all of you here, even though we all felt like we were trying to work around that, the other possible terms of what we do. So we can think of maybe data visualization as our medium and design as the way we get there, the way that we accomplish what our goals are, which are to create beautiful, engaging, and accessible projects that delight and inform the public. So we also really emphasize the beauty and the delight. We're meant to find ways to make this data that we're given to work with exciting and interesting to the public and informative at the same time. And those are sometimes at cross purposes, and our goal is to see if we can integrate those. We're never really trying to create, say, an answer for someone. We're not trying to model any situation, any system, or create a prediction. We're trying to create situations that the users and viewers of the data can enjoy and maybe ask questions that will then lead them into more complicated analysis. So I'm just going to show you, start with a few of our earlier projects, then move on to a little bit of what we're working on right now. I've been deliberately picking ones that are stretching, really quite far from what I think a lot of you might be doing. So I'm hoping this will spark some discussion, either in the Q&A period or throughout the rest of the day. One project we did several years ago called Crime Spotting. We made a San Francisco version and an Oakland version, just building on open data, the open crime data coming out of city governments. And this is not new. There were, in fact, one of the very first Google mashups was the crime map from Chicago. But those were push pins on a Google map, completely undesigned, all about just grabbing the data and working with it. This was, what we try to do is think about every element of the visualization. Think about what kind of push pins do we actually want, not just use the default ones. What kind of base map best supports that visualization? We think a lot about how to add these linked views in ways that are useful to the public, useful to people who are not trained data scientists and can figure out pretty quickly how to use these controls and so on. A few various iterations on that. But also what we try to do, so that was using design for pure function, like how can we make this as functional as possible. We also try to stretch the boundaries of what we can actually show with the medium of data visualization to make the data strange, unusual, or interesting. Here we're just using 3 different colors for 3 different data sets, where the crime data was, where cab data is, and where there are trees recorded in the city. And using the CMYK color scheme and just letting these things overlap. And you can sort of get senses of what kind of patterns are happening, where you can see certain neighborhoods have a lot of crime and a lot of trees, but the cabs don't go there, or vice versa. Whether this is actually a functional map that would let someone know where to place a business, where to buy property, it's not trying to do that kind of thing, but it's trying to make that data exciting for the public. Another really early project of ours called Cab Spotting. We did a lot of stuff with cabs and with crime. When you've got a good data set, just keep working on it, see what you can do with it. This was a project with the Exploratorium, and we had the GPS tracker data from all of the yellow cabs in San Francisco over a period of a few years. And this is a project where often design is about getting out of the way of the data, letting the data speak for itself. There's no content on this map. There's no base map. There's no annotation. It's merely the points where the cabs were located at some point in time. And then through that, it builds up a recognizable image of the city. You can see the spot over there on the right where all the cabs would go and refuel and change drivers and park over there, where just cabs are just sitting there. Their GPS trackers are just going for hours at a time. You can also start to see a bit about the data collection itself. So we know that this data is not pure, it's not clean. GPS traces specifically get messed up a lot by tall buildings and other objects in the way. So whenever the cabs would go downtown, you have the urban canyon effect where the GPS signal bounces all around and it doesn't actually know where it is. So what we're actually seeing is this is a story of tall buildings in a particular spot of a city, sensed through these observations from cab locations. We tried some other ways of connecting the lines from point to point. And it provoked a lot of questions as well. So why was the Bay Bridge sometimes looking really sharp in the data and sometimes it was totally messed up? As we explored it a little bit more, we realized that it was all of the trips going east that were not lining up with the bridge. All the ones coming west were working out perfectly. Why is that? Well, it's a double-decker bridge. So the cabs who are heading east are underneath the cover of the roadway on top, and their GPS signals are really bad. They would lose connection, and they would reappear again on the map over in Oakland once they're outside of that cover. So these are all things that we wouldn't have even known to ask of the data until you just start mapping it and showing everything on the map. But also we are known for our maps, our base maps that we use for other projects that are designed for specific purposes rather than trying to be something like Google Maps, which is meant to work for all generic circumstances. They don't know what you're going to do on Google Maps, so they make one map style that works for everything. We were doing a lot of data visualization, so we wanted a map style that works great for putting points on top of it or polygons, different kind of colors. We wanted a map that, of course, looked beautiful as well, but could recede and get out of the way when your data needs to have the center stage. So this is a style we call toner. Our base map styles are free to use for anyone. You can build them into your visualizations. There's plugins for R and so on. But also knowing when to make your map be really beautiful and aesthetic and strange. This is another version that we made at the same time called watercolor. Coming from the same data set completely, same raw lines and shapes and buildings from the same data, but styled completely differently. In this case, not at all meant for putting data on top, but that hasn't stopped people. There's actually lots of times where I see this on the web and people have put different colored pushpins on top of watercolor. And if they want to do that, that's fine, but it was not really, we never expected it to be used that way, never intended it to be used that way. We really cranked up a lot of these effects of blending the lines together, making them kind of blur into one another. And I think of this as a way of working with data. It's meant to look like it's made by hand, and those textures in the background are a real person watercoloring on a piece of paper. But all of the blurriness that looks hand done is just algorithms. It's just processing raw data into new and different ways, which in some ways makes you stop and linger and look at these buildings, and look at these roads in ways that you might not have done before. So it's really, I think of this as treating maps as data, but with a different goal. Not necessarily to come up with any kind of answers or even something that's functional, but rather to create a different effect from the same data and to make them very inviting. So what we like to think about is what we're building are not answer-making interfaces. They're question-making interfaces. And I don't want to try to stereotype what I think data science might be versus data visualization, and I hope that we can come up with a more nuanced conversation. But no one comes to us really to get an answer out of their data. They come to have us provoke them with questions. And in many ways, the analysis that most of you are doing with data science is trying to get at similar things, but you're often also hoping to get some kind of answer to a question at the same time. So maybe that's where data visualization can be seen as a complementary to data science. It's certainly not exploratory data visualization either. It's not really, we're putting the data into some software and fitting a bunch of models. It's not that kind of exploration. But it is meant to provoke questions in the reader, in the viewer. I wanted to fairly quickly talk about my background, how I got into this. So I am studying this thing called OpenStreetMap in my dissertation research. OpenStreetMap is Wikipedia for maps. Hopefully some of you have heard of it. We use it all the time in all the maps we make. It's basically a free Creative Commons licensed map of the whole world, and you can get the raw data and do whatever you want with it. So I'm studying the community aspects of that data. Who creates it? Why do they volunteer for this project? How do disagreements get settled? So all the arguments that happen in a Wikipedia article happen over lines and roads and points in OpenStreetMap as well. And so our maps, the toner maps and the watercolor maps that we make at Stamen are all derived from this data. So what I'm trying to do, and I was working on this at the time I started at Stamen, and Stamen is supporting this work further because we feel like we need to understand this community of volunteer data producers that we depend on. I was trying to get at the questions of who created the map to begin with, who started adding to OpenStreetMap, and did those people stick around to continue to maintain that map? Are they data gardeners now, or do they leave after mapping their city for the first time, and then it's new people who come in? So what I did was just loaded in the entire history file from OpenStreetMap. You can get every previous version of every feature that ever existed. And I overlaid a grid. I found what is the earliest node, the first point added in each of these grid squares, and who was the volunteer editor who added that. And so then I did some analysis on the editing logs. And this is the only scatter plot I'm going to show you. Actually, I've got two. But this is where I was trying to go. But as a geographer, we're also, in the geography departments that I'm familiar with, we're also torn between this idea of scientific approaches to data and then very qualitative ethnographic approaches to the world around us. And my own research was kind of torn between these two axes. So I came in and I was doing these kind of things where you can compare the editing community of OpenStreetMap in London with the one from San Francisco. And you can see those who created these blank spot edits are the people who first added to the map. And then these are all your total edits after the fact, after you first populated it and you've continued to maintain that data. And then the size is the number of total edits for each person. I'm not going to get into what I was finding from that. I am still working on this research, but when I brought this into Stamen, they're like, can you just go back to those maps you were first making to overlay the data? Those are interesting. Those maps basically of loading all the features into the database and just drawing them all, just like clicking draw without really choosing, well, which date am I going to draw, what type of feature. I'm just going to draw everything in there and draw them really light, but just let it stack upon each other. So here's London. Every linear feature in OpenStreetMap just piled on top of each other, and things get darker as features have more and more modifications. And you can see things in here. My colleagues found stuff in here that I was not even looking for. There's this park down here in London where someone had written their name on the park cane. So these things get deleted from OpenStreetMap pretty quickly. It's like Wikipedia. You can vandalize it all you want, but there's enough good people who are keeping things clean and checking all the pages that they'll fix the vandalism really quickly. So the vandalism on the map gets fixed really quickly too, but it's all still in there. The traces are still in there in the data. And I never would have seen that if I hadn't been prompted to just draw everything and really browse around and explore it. Here's the same thing for San Francisco and Oakland. And what's interesting also is that this is telling us something about what things are important to these volunteers. People are editing the freeway a lot, so it gets darker. You see it moved around a little bit as they refine the shape over time and as they add attributes to that data. So without even saying, I'm going to make a map where I'm going to draw freeways dark and I'm going to draw major streets sort of dark and alleys very lightly, it comes out automatically just through the collective effort of thousands and hundreds of thousands of volunteers. So it's really fascinating stuff that is coming out just by drawing everything. Another project I just wanted to show was we visualized some data from NASDAQ. We were hired by NASDAQ to find some way of making IPOs more interesting to the public. They wanted something that was better than just like a chart that goes up and to the right. But beyond that, we weren't really constrained, and we just got a day's worth of data, and we're like, okay, we're going to see what we can see in here. So what we're showing here now is, to the right is time. Now this is just like a microscopic view of the market, of all the purchases that are happening, all the trades that are happening over one day. The value of the stock goes up, so the ones along the top are higher valued stocks, and the size of the circle is the total value of that trade. So of course, ones near the top tend to be larger, but you can also just buy a single stock of a high-priced, a single share of a high-priced stock, and you would show up higher on the map. And you colorize it, we can colorize it by stock, and so we see that this yellow dot is one stock that is over this tiny microscopic view of the data, relatively flat. But we can also look at the traders. And this is where we started to find some really interesting things, because you can see these giant traders on the market who are buying and selling hundreds of thousands of shares. You know, these are big mutual funds, these are big clearinghouses, these are those algorithmic traders as well. So we start to see a lot of robots in the data. You see things like this square shape where there's a bunch of purchases that are all really tiny of a ton of different stocks, all for a short period of time. And if we colorize it by trader, we realize that was one trader who was kind of hitting the market with a whole bunch of requests all at the same time. and here's another kind of vertical band of blue. And these are really showing these robots that are working in the market that we don't normally see, that you can't really see how they relate to the rest of the market. I'll just flip through a few more of these. And it's also really great to animate this. So I'm going to scroll through a whole bunch. This is a little bit before the opening bell. We see there's these little bursts of activity of trades that are happening outside of normal trading hours. But they're all tiny. And then here comes the opening bell. These are like all the giant trades everyone has been waiting to do for the market to open. And then after a few minutes, that dies down. And then there's this steadier flow of activity. But all throughout here, you can see there's these individual pings from robots testing the prices of the market and so on. I'll move through this one pretty quickly. But again, not all of our visualizations, as I'm saying, are totally meant to show this unusual look at the data. Sometimes we are using design to think as clearly as possible how to communicate one clear message that has already been produced elsewhere, or some data that's already been produced elsewhere. So this is a project with Climate Central trying to show sea level rise. There's tons of maps out there that are trying to do this. Everyone kind of knows this is a problem, that we're all going to be flooded soon, and this is not really something where you need to communicate to the public, hey, guess what? Sea level is going to rise. It's more how to make this personal, how to focus the attention on specific areas. And most of the time, these maps will show, here's a future scenario where parts of the land are underwater, and you can see this is where Manhattan is now with a bunch of water around the edges. We reversed that, and instead we relied on that toner style, the ability of this black and white map to kind of recede and get out of the way. And instead what we did, we were showing satellite images only in the parts that are being flooded. So kind of reversing the order of what you would expect to do with the data to really draw attention to what is being lost rather than to draw attention to what is still going to be more or less fine in the future. And we're working on a revision of this for California. This is just for the East Coast, so within the next few months we'll have a version of this for California out too. We also have some versions where it emphasizes where the population density or where the areas of social vulnerability. So this is a neighborhood that is about to get flooded, but it's relatively well off. They'll be fine. We should focus our efforts on this low-income community that is going to need more assistance relocating once the flooding happens. And this is the last project that I want to talk about, which we've just launched very recently. And there's still more versions of it that we're working on. So this is where if you have any interest or ideas in working with us, we would love to hear about it. We were tasked by a nonprofit to create social media dashboards for parks and open spaces in California. The idea being that if I'm a park manager and I want to know what's going on in my park and I don't want to use the old-fashioned ways of surveying the old people who tend to show up to my park meetings. Like, I know that other people are using my park, but I can't reach them, I can't access them. Maybe I can see what's going on via social media. So what we did is we grouped all the parks, we sort of extracted them from their natural geography, and you can sort them by various metrics according to the social media that we have collected about what's happening in those parks. But we found that in our focus groups with park managers, they didn't want dashboards of data. They didn't want to know what was trending. They didn't know if they had more Flickr photos today than yesterday. They wanted something they could glance at and get more of a feel of what's going on. So we're just really letting the data become the images coming from, say, Flickr, from Instagram. We've got a feed of tweets, which is further down. We're actually hiding all of that interesting data analysis and rather just giving this effect of what we're collecting out of that. But of course, we had to collect those Foursquare venues and those tweets. And it looks like, in a sense, a map of population, but really these are all Foursquare venues that occur in parks. So it's really a map of small parks and large parks outside of urban areas. And of course, collecting that data was super interesting data analysis challenges, but it's not really interesting to the public. So we're figuring out how can we use this in some other interesting way. One limitation, for example, some of these APIs, I can ask Foursquare for a bounding box and say, give me all of the venues within that bounding box, but it gives me a limit of 50 back. So if I hit 50, I need to subdivide and query again. For Instagram, the same thing. I can ask for, give me all the photos within a bounding box or within a circle, but they hit me with a limit. Like you only get 100 back. So I have to subdivide smaller and smaller. So you get these really interesting patterns of where are the high density areas of social media in parks only. So this is stuff that we've just been producing in the last few months. We don't really know what we're going to do with it, but we feel really excited by this different way of seeing where things are. We're also querying the Foursquare API to see where are venues that people check into next after being at this park venue. So we could find out that the venues within Alcatraz, people tend to check in at another venue. But some other places, everyone checks in. People check in at parks all across the East Bay, but then the subsequent place they like to check in is an ice cream shop. Everyone goes to the park and then an ice cream shop. So maybe we can use this kind of analysis to figure out, argue for parks as economic drivers in the community, and so on. These are all early questions that we'd like to do, but stuff that we can't really use for the main goal of our website, which is to make these things that are inviting and useful for parks managers themselves. Thank you. I guess I didn't leave much time for questions.
Time for one question. Any questions from? Did you show the bus maps?
I didn't show the bus maps. Yeah.
They're responsible.
We also did the Silicon Valley Google bus maps or the tech bus maps, and which was also really interesting. We had to collect that data ourselves. We normally let people bring us data, but that was one where that data wasn't available to us. We hired bike messengers to follow the buses around and build up this data of where they actually were.
It's a staggeringly insightful
Yeah.
set of maps.
Yeah, and we did that for the 01 Silicon Valley Arts Festival. So yeah, just like search for Stamen in the Google bus map and you'll find it.
Go on their website and look for the Google bus map. It is very
One of our few on-the-ground data collection.
It's a great project.
Thank you.
Thanks again, Al.
Thanks.